morning, everybody, and welcome to our pre-calculus 40S class. So today what we're going to do is we're going to take a look at lesson 5. And basically yesterday, the things that we talked about in yesterday's notes, I know we did quite a bit, but those are the groundwork that leads to this topic. Before I dive right into this one, I just want to kind of review what we talked about before. So I'm going to try to review the following before getting to that one. Okay. Because we're going to see it quite a bit. So the we looked at the reciprocal identity. So when we see sine, we can write it as 1 over cosecant theta. If we see cosecant theta, we can rewrite it as 1 over sine theta. So we're going to see some of these reciprocal identities later on. So cosine theta, we can write it as 1 over secant theta. And then if we have secant theta, we can rewrite that in a different way, which is 1 over cos theta. Tangent, we can write it as 1 over cotangent. Cotangent, we can write it as 1 over tangent. And these are the quotient identities. So I guess I didn't really put a box there. It doesn't really matter to highlight that. So when we see a tan theta, it's really a sine theta divided by cos theta. If we see a cotangent theta, we can rewrite it as cos theta divided by sine theta. Okay, so we talked about that one. And then the other thing that I want to point out today is this one. The Pythagorean trig identity, where it says cos squared theta plus sine squared theta is equals to 1. We want to, if we see something like this, cos squared plus sine squared of theta, we can replace that with just 1. Okay, we're going to see it today. Another thing that I want to point out is this part here. When we see it's connected to, these are connected to that one. Well, I guess it's right here. So another version of this. So if we see cos squared theta, we can write it as 1 minus sine squared theta, or vice versa. If we see 1 minus sine squared theta, we can replace that with cos squared theta. If we see 1 minus cos squared theta, we can replace that with sine squared theta. So those are just kind of a review that I wanted to talk about because we're going to see it quite a bit in our lesson for today. Not so much for this one because in terms of trig identity, the basic idea is to write it in terms of sine and cos. So what we're going to do is we are going to take a look at proving the identities. I'm not going to spend so much time on identifying the non-permissible values, okay, because I just want to focus on the trig, what do you call that? Trig identity, proving. So proving the trig identity. And so let's start with this one. When we're looking for a proving identity, the key thing is that usually this is what I do. I start with the more complicated side. Okay, so like for example, this one here. So cos of x times secant of x is equals to 1. So I'm going to start with this one here because this is more complicated and work it out so that I can see that it boils down to just 1. Okay. Also, even though that there's an equation, okay, what we're trying to do is we're going to prove that the left side is equal to the right side. So there are no transferring of no transferring terms. No transferring of terms on either side of equation. Okay, so we're not going to say, oh, I'm going to transfer it over there, or right, or set this side equal to 0. No, we're not. No transferring. Okay, so I think that's about it. And then if there's something that I think about later, uh, we'll talk about it. I'll put it in. Okay, so let's start with this one. So we are going to have this. This is going to be the left side. Okay, and then this is the right side. I'll just put, so what I'm going to do is, okay, let's bring it a little bit closer so we can see it properly. We're going to work out or start with the more complicated side and see if we can simplify it in a way that it looks like the right side. And that's how we are going to prove it. So cosine. So we start with the cosine of x times secant of x. Okay, so how do I work this out or simplify this so that it looks like the right side? Okay, well, what do I know? What do I know? I know that secant of x is, we can rewrite it as secant of x, I can write it as 1 over cos of x, right? So that's that. So secant of x, I can write it as 1 divided by cos of x. And I still have the cos of x here. Okay, now you can see, oh, I see that cos of x divided by cos of x, so they cancel each other out. So we're left with 1. So my left side is equals to 1, and on my right side is equals to 1. I'll just bring that down here. So therefore, the left side is equal to the right side. Okay. So that one is a great start, because starting really start with something simple. Okay. So now let's take a look at letter B. Letter B. So which one can we start off with? The left side is that, and then my right side is that. Okay, so tan of x times cos of x is equals to sine of x. So what we're gonna do is, I would usually start with the more complicated one. So this is a complicated one, and then this one here is not as complicated. It's actually very simple, sine of x. So how can I work this out? Okay, using some of the identities that I know to simplify and make it look like the right side. Okay, so what do we know? Okay, what do I know? Okay, tan of x. What do we know about tan of x? Hey, we can write tan of x as sine of x divided by cos of x. Okay, so that the tan of x, we're replacing it with sine of x divided by cos of x, and then the times cos of x is still here. And let's see. Oh, okay. Now I see that the cos of x and the cos of x cancel each other out. So now this is just simplified to sine of x. Okay, so the left side, we've worked it out. We've simplified it using some of our trig reciprocal identities, or the quotient identities, and then simplify for that one. So now the left side is sine of x, the right side is sine of x. and we don't have to do anything here. So the left side is equals to the right side. Okay, so those two are not bad. Okay, now let's take a look at letter C. Letter C. Okay, so which one should I look at? On the left side, this is my left side, and then tan of x is the right side. Now, we don't always have to solve the left side. It just looks like we're always simplifying the left side, but whichever is the more complicated one. So let's take a look. What do I know about this? Secant of x divided by cosecant of x. Okay. I want to use some of the identities that I know, trig identities that I know, to make it look like tan of x. Okay. So I'm going to work this out. What do I know about secant of x? Well, secant of x is the same thing as, secant of x is the same thing as 1 over cos of x. Okay, so we can rewrite secant of x with 1 over cos of x. And then divide. What do I know about cosecant of x? Oh, well, we know that the cosecant of x is 1 over sine of x. Okay, so now we've kind of created here a complex fraction because you have a numerator of a fraction is a fraction, and then the denominator is a fraction. So a fraction divided by a fraction is kind of a more complex, or it's called complex fraction. So how do we deal with something like that? So what we can do, I'm going to put the equal sign there. When we're dividing, when we divide, we can say it's the same thing as multiplying the reciprocal. So I go 1 over cos of x, and instead of dividing 1 over sine of x, we can write it as times, let's put a dot, the reciprocal of that. So sine of x over cos of, no, oops, sine of x over 1. So 1 over cos of x divided by 1 divided by sine of x is the same thing as multiplying the reciprocal of the denominator. So what do I know? Well, 1 times sine of x is sine of x. Cos of x times 1 is cos of x. And when you look at this one, oh, sine of x divided by cos of x is tangent of x. Tangent of x. So that means, okay, we see the left side when we simplified this expression. Okay, we're just looking at this expression in here. We simplified it, it's tan of x. And then the right side is also tan of x. So that means the left side is equals to the right side. So we've proven that this secant of x divided by cosecant of x is really just the same thing as saying tangent of x. Okay, so those ones are not so bad. They're actually pretty nice. So let's take a look at letter D. Okay, letter D. Like, it's getting better, of course. We're looking at the baby steps here. The next little bit, it gets more complex. So how do we do it? How do we do this one? So this part, cos squared of x, is the left side. And then all of these is the right side. Okay, so what I'm going to do, okay, what I said earlier at the beginning is start with the complicated one and see if we can simplify this, clean this up to make it look like that. So left side is just cos squared of x. So that's just leave it like that. And then here, what can I do here? What do I know about cotangent of x? Okay, well, cotangent of x, we can write it as, okay, actually I'm gonna give a hint. So usually when you have something like this, you just break it down to just sine x and cos x. Okay. Yeah, it takes a lot of practice to do these things. So when we see something like this, it would be nice to just break it down into sine of x and cos of x and then go in from there. So cotangent of x, what do I know about cotangent of x? Cotangent of x is really cos of x divided by sine of x. Okay, that's what cotangent of x. And we're supposed to multiply by sine of x, so times sine of x. Okay, so that's just the numerator part. Now the denominator looks like secant of x. Well, what do I know about secant of x? Secant of x is 1 over cos of x. Okay, so as you can see here, we're using a lot of the reciprocal functions. Okay, now what can I do? I see that in the numerator, we can cancel sine of x. Okay, that cancels each other out. So what is left behind? What's left behind is cos of x over 1, which is just basically cos of x. And then what's in the denominator? Denominator is still 1 over, cos of x. 1 over cos of x. So how do we deal with this one? What do we do when we have a complex fraction? Because this fraction has a fraction in the denominator. It's the same thing as multiplying the reciprocal. So we can say cos of x times the reciprocal of the denominator. So that becomes cos of x over 1. And then what we can see here, cos of x times cos of x, that's going to be cos squared of x. Cos squared of x. So now, look at that part. This is the left side. If you want, you can just leave it like that. Okay. Left side is equals to the right side. Or if you want to bring it down, that's okay too. You can just go cos squared of x. Now you can see that they're the same. Okay, so what that really means is that this cotangent of x times the sine of the x, these are angles, right? Divided by the secant of the angle x. Really, it's the same thing as squaring cos of x. Okay. Now we're going to get into a little bit more complicated stuff, right? Not super complicated, but it's okay. So which one can we start off with? Okay, so which one can we start off with in this particular case? I'll go this way. So this one, the right side is just cosecant of x. Okay. And then all of these is the right side. Okay, remember, we're not transferring anything left and right. We're going to work this out, right? Simplify it as much as we can so that the left side is equal to the right side. And that's what we're trying to prove. Okay, we're not trying to solve it. We're trying to prove it, that it is true. So what do we know? Cosecant of x times cos squared of x plus sine of x. Okay, this is a little bit more than what we had previously. So again, same thing. What we're going to do is we're going to take a look at how can we break this down to make it look like that. Well, what do we know about cosecant of x? So, okay, well, cosecant of x is the same thing as 1 over sine of x, okay? And then the cos squared of x, I can just go like that, cos squared of x plus sine of x, okay? Well, what can I do? Okay, well, nothing cancels in here. So what we can do is we can write it as one fraction. Okay, so this line is equal to this line. Okay, now going to the next line. 1 times cos squared of x is just cos squared of x over sine of x plus sine of x. Okay, so this first line is equivalent to this next line, and then this second line is equivalent to the third line. Okay, so how do we do this one? How can we, is there a way to add these two together? Well, this, if there's nothing in the denominator, we know it's 1. So to combine these two as 1, we need to have the same denominator. So what do we do with that one? We need to multiply by here, by sine of x divided by sine of x. So I won't skip the step. I'll actually show all the steps in here. Cos squared of x over sine of x plus sine of x over 1. So what I'm going to do is I'm going to multiply by sine of x over sine of x. Okay, so what does that look now? I can go cos squared of x plus, well, sine of x times sine of x is sine squared of x. Okay, and then this one is sine of x in the denominator. And sine of x in the denominator there. Okay, good. Now that they have the same denominator, we can combine them. We can add them together. So it could be cos squared of x plus sine squared of x over sine of x. Okay, so this is the same denominator. We're just putting it all in one denominator. Okay, so what do we know? Oh, okay. What else can we do? Okay. How can we make this look like cosecant? You probably realize, okay, cos squared of x plus sine squared of x. This is a Pythagorean trig identity, right? Cos squared of x plus sine squared of x is equals to 1. Divided by sine of x. Okay, and then, 1 over sine of x is the same thing as cosecant of x. Okay, so there we go. We've made the left side. Just going to extend this one. We've made the left side equal to the right side, cosecant of x, right? Left side. Now the right side are equal. That's good. Okay, so that's awesome. That's really awesome. Now, now what we're going to do is we're going to take a look at letter F. Um, letter F. Okay, what can we do? What can we do? The left side is pretty straightforward. It's just cotangent cube of theta. Okay, so that's just the left side. But then the right side is a little bit more complex. So that's all of that. So what can we do? Well, we got to start with the right side and see if we can clean this up and make it look like cotangent cube of theta. Okay, so let's write it in. I actually have on my notes here, I have two different strategy to show this one. So what I'm gonna do is I'm gonna show one strategy, and then if you want, um, I will also post the other strategy. Okay, so yeah, because we don't have a lot of time, I want to make sure that I get all of these done in a good time. So I will do one way of doing this, and then uh, I will post it on the notes the other way of proving this. Okay, so here we go. What can I do? So cotangent, what do I know with cotangent? Cotangent is the same thing as cos theta over sine theta. Okay, so that's that part. Times cosecant squared theta. Okay, well, cosecant is the same thing as 1 over cosecant theta is going to be 1 over sine theta, but then this is a squared, so it's going to be 1 over sine squared theta. Okay. Okay, and then minus another cotangent. Another cotangent would be cos theta over sine theta. Okay, so this part, oops, you can't see that, sorry. And this line is equal to that line. And then I just change it in terms of sine and cos. Okay, now let's see if we can simplify things. Nothing cancels, okay, so that's okay. But we can simplify it. So cos theta times 1 is cos theta divided by sine theta times sine squared theta is going to be sine cubed theta, okay, minus, minus, well, these ones we can't really do anything, so I'll just put cos theta divided by sine theta. Okay, so now we have these two terms, and then this is sine cubed theta, okay, cubed. Okay, I want to make sure it's cubed, not, it doesn't look like 3 theta. Cube theta. Okay, so how can we combine these two fractions? So think of it as a fraction. How can we combine these two fractions? The only way we can do that is if we have the same denominator. So what's the lowest common denominator? Well, this is sine cubed theta. This is just a sine theta. So that means we need to multiply by sine squared theta, right, to make it sine cubed. So we're going to go here. I'll just put here sine cubed theta divided by sine cubed theta. So the red part is basically the one that I'm multiplying in to make it the same denominator. So it equals, what does it look like now? It becomes cos theta minus, oh, this is going to be interesting because now this is cos theta times sine, oops, I, I don't need cube, I need 2. Sine squared theta divided by sine cubed theta, and then this one here, sine theta times sine squared theta is sine cubed theta. Okay, so it looks like we got even to a much bigger mess. So let's see what's going on in here. Okay, what can I do? Now that I have these two the same denominator, I could probably combine them. So let's combine them. It's going to be sine cubed theta. And then the numerator would be cos theta minus cos theta times sine squared theta. Okay, that looks like it's a mess. So what can we do? Okay, well, a possibility is to factor out the cos theta, and then you'll see why. We'll see why. Okay, so what we can do is we can factor out the cos theta, and if we factor out cos theta from the numerator, we're gonna get 1 minus sine squared theta, and then the denominator is still sine cubed theta. Okay, so what do we do next? We probably realize, oh, 1 minus sine squared theta, that's one of the Pythagorean trig identity. It's going to be 1 minus sine squared theta. That's the same thing as cos squared theta. So this is cos theta times this part here is now cos squared theta over sine cubed theta. Almost there. Cos theta times cos squared theta, that's going to give us cos cubed theta divided by sine cubed theta. And then, well, if you have cos cubed theta divided by sine cubed theta, remember it's sine divided by cos is cotangent, but it's cubed. So this is cotangent cubed theta. So here's one strategy that I have. Sometimes there's more than one way of proving something, right? One way of proving something. So this is going to be cotangent cubed theta is equals to cotangent cubed theta. So that means left side is equals to the right side. Okay. So I'm just going to have a little note here. There is another way of proving this identity. I'm just going to write down C separate page. Okay, so I'm going to restrict it to just 1 hour of lesson because I know I've been going overtime lately and you probably need some time to do some work. So what I'm gonna do is I will another way, and then you can have a look, see if you can follow along, see if you can see what I'm doing differently, but we will come to the same conclusion. Okay, so that's that. Okay, now we're gonna go to letter G. Okay, we only have G and H. G and H. Okay, this one is kind of interesting. It's kind of interesting, letter G, because which one should I start with? Because they're both kind of complicated to me. Oops, wrong one. They both kind of look complicated. So what can I do? What can I do for this one? Um, so here's another thing. Um, let's say you are absolutely, let's say you start off with this one in here, and then you got stuck and you can't go on anymore. And then you go to, and you can't make it the same. Okay, like you tried your best and you can't make them the same. So what you can do is you work out the other side, and then if you work out the left side and then you see like you can't work anymore, and then you work on the right side, and if if you work on both of them, and then you can, if you're able to show that the left side where you got stuck on the left is where you got stuck on the right, and that means it's the same. Okay, so as long as you make the left side look like the right side, it should be good. So I thought I'd mention that one. Now, yeah, like in this particular case, like I said, they're both kind of complicated. I actually have two different ways of doing this one. I'm gonna again write down the notes with you here, my one way, and then I'll do the other way on a separate sheet of paper, and then I'll just have it attached with our notes. Okay. So what can I do? What can I do? I'm gonna start with. I'm gonna start with. I'll start off with this one. Okay. I'll start off with this one and work my way to make it look like that one. Okay. So this is my left. This is my right. Okay. So what does that look like? Cos of x times sine of x divided by 1 plus sine of x. Okay. So in this particular case, nothing cancels. Nothing cancels in here. And can't really, because there's no reciprocal things to simplify. Okay. So here's the one possible solutions that I have. Okay. Is what I did is I have to somehow form a 1 somehow. So sometimes I did this. That's what I did. I multiplied by cos of x over cos of x. Okay, now you're probably thinking, okay, why? Let's see. Now what can I do? Cos of x times sine of x times cos of x, that's going to give us cos um, cos squared of x times sine of x. Okay. Now what goes in the denominator? The denominator, what I did is I kept this 1 plus sine of x times cos of x. Okay, so just multiply those two. Okay. So what do we do? What do we do now? Okay. Cos squared of x, what we can do is we can change that into um, 1 minus sine squared of x. Okay, so cos squared of x, we can change that into 1 minus sine squared of x. So looking at the Pythagorean trig identity, times sine of x divided by 1 plus sine of x times cos of x. Okay. Okay, so what can we do? What can we do? Now, this is a difference of squares. We're actually going to be using the factoring strategy here. We notice that, hey, this is a difference of squares. Because this difference of squares, I can change it to 1 plus sine of x times 1 minus sine of x times sine of x. Okay. Divided by 1 plus sine of x times cos of x. Mm-hmm. So let's see if we can follow. Okay. We started off with cos of x times sine of x divided by 1 plus sine of x. Nothing cancels in here. These two can't cancel because this is a 1 plus sine of x. So we can't cancel these two. So the way I was thinking is, okay, I could multiply this by cos of x over cos of x. It's basically multiplying by 1. And then when I multiply this, it creates the cos squared of x times sine of x. Okay, so these two cos of x will give us a cos squared of x and then times sine of x. And these two, instead of expanding, I kept it separate. And then, because this is a cos squared of x, we changed it into 1 minus sine squared of x, which is a trig identity, times sine of x divided by that. And then here, we realize, hey, this is a difference of perfect square. So 1 minus sine squared of x, we can write it as 1 plus sine of x times 1 minus sine of x. And then the sine of x is still there, and then the denominator still stay the same. Now you're probably thinking, oh, I see something that can cancel. I see something that cancels. So what cancels is this. This cancels. This cancels. So those two cancel. So that is pretty good. Okay. Now I can see, I'm just going to go back up a bit so we can see what's happening here. Over here, I see 1 minus sine of x. 1 minus sine of x. And then these two, sine of x divided by the cos of x, is really the same thing as tangent of x. Okay, I'm going to write it down. 1 minus sine of x. And then the sine of x divided by cos of x. Sine of x over cos of x. Okay, I take that outside. And that's the same thing as tangent of x. 1 minus sine of x is equal to the tangent of x. Okay. And then, well, if tangent of x is the same thing as 1 over cotangent of x. So 1 minus sine of x is the same thing. Tangent is 1 over cotangent of x. So multiply them together. It's going to be 1 minus sine of x in the numerator. And then the denominator is cotangent of x. Okay. So the left side now looks like the right side. 1 minus sine of x over cotangent of x. Okay, so left is equals to the right side. Now there's probably other solution to this one. I have another solution for this, and I will post it on the notes. So I'll write it down here. Please find another solution on our notes. Okay, so I'll post it on our notes, and then take a look at it. And there's if you so there could be other ones. Okay, so that's a great thing about this one here. Proving identity, you could have more than one possible solution. Okay, so now we are down to our last example. Last example. Okay, let's see this. Oh, this is not bad. So I see the complicated side here, and then the other side is just cosecant of x. Okay, good. So the left side and my right side is the cosecant of x. Let's see. Sine of x plus cotangent of x over secant of x. Okay. If I clean this up, it should look like cosecant of x. Okay. So I start with the complex one. What can I do? I can go sine of x plus cotangent of x can be written as cos x divided by sine x divided by, okay, secant, we can write that as 1 over cos. Okay, so already here we've gotten a complex fraction because the fraction has a fraction in them. So let's take a look. Let's see if we can simplify that. Okay, so sine of x is still sine of x plus complex fraction cos of x divided by sine of x divided by 1 over cos of x. So dividing fraction is the same thing as multiplying the reciprocal. So I can write down cos x over sine x times the reciprocal cos of x over 1. Okay, so that's great. Um, let's see if we can simplify that. So sine of x plus, simplify these two, cos of x times cos of x is going to be cos squared of x divided by sine of x. Okay, great. So what I could do, okay, what can we do? Well, this denominator is 1, right? When there's nothing in the denominator, it's 1. We need to have the same denominator, common denominator, to be able to add these two together. So what are we going to do? We're going to go sine of x over 1. I'm going to go sine of x over sine of x. Okay, so that's the one that I had to multiply to get the same denominator. Plus cos squared of x over sine of x. Okay. Now you're probably seeing something already that's coming along. So sine of x times sine of x is going to be sine squared of x over sine of x plus cos squared of x over sine of x. Okay, now these two fractions, they have the same denominator. We can combine them. So let's combine them. Equals sine squared of x plus cos squared of x over sine of x. And then you probably realize, oh, I see this. Sine squared of x plus cos squared of x is the Pythagorean trig identity, and that is equal to 1. So equal to 1 over sine of x. And then 1 divided by sine of x, so that's a reciprocal, right? 1 over sine of x is the same thing as cosecant of x. So there we go. We proved that the left side is cosecant of x, and then the right side is cosecant of x as well. So the left side is equals to the right side. Okay, so that's really great stuff. So we did finish the notes on time. So the practice questions for you to try are some of these questions we did yesterday. Questions 3 to 5. I've already posted the solution for those things, so you can work on the rest of the questions. So there's a lot of questions in here that are okay. Sorry, you can't see that. So questions 3 to 5 were already assigned yesterday. Um, if you didn't get a chance to, if you didn't get a chance yet to do those questions, I would say try those questions first. Okay, so it talks about simplifying and all that stuff, and then verifying, and then carry on with the rest. Okay, so there we go. I am continually posting the solution on the blog. I'm hoping that you um, are benefiting from that. And if you have any questions, like please don't be shy. Um, just tell me which question that you wanted to see. I and basically the reason why I'm posting all the solutions is nobody has been asking questions. So I'm hoping that even if you don't ask questions, okay, the solutions are there and you can read it. And if it's still not clear to you, yeah, come and ask me and let me know how to do certain things. Okay, and then we'll try to find a way to answer your questions. Okay, so I want to take this opportunity to thank you for participating in our live stream today, our video today on this topic. Um, and like I said, if you have any questions, please do reach out to me. And yeah, we'll we're almost done. I hope you are getting super excited about finishing the course real soon. I sure am quite excited about the course being done soon. And yeah, we'll keep at it. And thank you for watching, and thank you for doing your test and handing it in. I appreciate that. Now that one I will hand back to you as soon as I'm done. Okay. Thank you so much, and I wish you have a great day. Okay, I'll talk to you soon. I'll talk to you tomorrow. Okay, bye for now.